listening to the Virtual CISO Podcast, providing the best insight on information security and security IT advice to business leaders everywhere.
Hey there, and welcome to yet another episode of the Virtual CISO Podcast. With you, as always, your host, John Verry. And with me today, Curtis Griffin. Hey, Curtis.
Howdy. It's good to be here.
Thanks for coming on. Looking forward to chatting. I always like to start off super simple. Tell us a little bit about who you are and what is it that you do every day.
Yeah, Curtis Griffin. I'm a senior manager with CBIZ Risk Advisory Group. It's part of the CBIZ organization. And more specifically on the information technology and cybersecurity consulting side.
Thanks for coming on. I always start with another question. What's your drink of choice?
Honestly, I drink a lot of Coke. It's kind of boring, but simple. Probably been doing that way too long since I was a kid. I've had to back off a little bit as I've gotten older.
You haven't seen the press releases that say that Coke's not healthy for you, have you?
Yeah.
I don't want to ruin it for you, but I think you should know that. You know what I mean?
I appreciate that. Yeah, I've heard.
Right.
I've heard such. And the sad thing is the diet stuff, I think is worse for you. And I find it disgusting. So I'm fully with it.
I would agree with that. I think they're both bad for you. It's just which it's a matter of which is the lesser of two evils, right?
Yeah, I might as well take the sugar.
There you go. Thanks for coming on. Over the last few years, the term operational technology has increasingly crept into conversations. I think it's largely driven by the risk associated with operational technology, and increasingly more guidance from the U.S. government relating to it. So let's start by just defining what do we mean by operational technology or OT?
It's the term is expanding, I think, faster than we realize. But generally, my definition is, where technology touches the real world beyond the screens and the keyboards. Obviously, we have screens and keyboards in both areas, but technology that's aware of its surroundings. Taking measurements, pressures, temperatures, flow rates, but also, things like, smart cameras that know what's going on outside its little electronic brain. But also stuff that has the ability to do things in the real world. Turn on and off power, start generators, open valves, close valves, control flow rates, control robots. That's stuff, that touches that makes that leap into the rest of the world. I think the difficulty when we start talking OT in our world is that everybody starts thinking industrial control systems or SCADA. But these days, I think it's merging into the Internet of Things. People have smart refrigerators in their houses, smart light switches, and they don't think of that as operational technology, but it really is. It's got a computer in there. It's talking to other devices, but it's also controlling, our homes, our factories. It's controlling fish tanks. I remember several years ago there was a hack against a fish tank in a doctor's office. Killing fish is not great, but it's not life ending. But when you start extrapolating those types of devices out into the rest of the world, nobody was thinking operational technology when they hooked up an Ethernet cable or Wi-Fi to their fish tank.
Yeah, one of the things that's interesting that you said is that that line between like IoT and OT has definitely blurred. I think when most people think of OT, they think of I'm going to say non-IP, as in internet protocol, conventional communications. I think we tend to think of the OT technology as being something running other than that, like DMP3 or something of that nature, right? But it is interesting though that the things that make something OT are also the things that make something IoT, but now with a different set of standards and requirements and risks that are associated with them.
Yeah, I really think that that transition, I think there's been a curve. We still have the devices in the field or, things that just talk old, I'd say older protocols, Modbus or even just, standard serial stuff. We still have all that stuff, but when I'm going into clients and we're talking OT, they are thinking about that stuff, but when talking about cybersecurity, it's closer to our more traditional IT protocols and technologies, systems, and the problem is and I'm sure we'll get there. Stuff that we've traditionally said, oh, it's a Windows system. Well, OT wants that because the flexibility and everybody's developing stuff for a Linux kernel, and so might as well bring it into their world. So
right.
I'm seeing that a lot.
Right. So with many IT professionals, the minute you start talking OT, they get a little bit nervous, they get a little uncomfortable, right? It's unfamiliar. But fundamentally, when I look at it, right, there are as many or more similarities than there are differences, right? And at this point, I'm going to call it traditional OT, like the factory stuff that we're talking about, the non-IoT type. So talk about those similarities, right? How can somebody who is listening, that's an IT person, kind of analogize or get comfortable with OT?
Well, I think you're right. I think that there's a lot of similarities, and there's been this hard line in the sand where, or maybe even a fence between OT and IT. That they've got their stuff, I've got our stuff, but getting past that, it's completely foreign. I mean, we are talking about just hardware and software. Whether it's a PLC, it's just a computer, and it may be running, a RTO, a real-time operating system, that's super fast, super efficient, does one thing really, really well, doesn't like disturbances, as opposed to a kernel that's running all sorts of things all the time. But it's still, hardware and software. And I think getting to that point, I've not done a lot. I want to emphasize I've not done PLC programming, but I've done some ladder logic. Got it into the middle of it and seen, and it's just computer programming. Whether it's just a different interface and a language that most programmers aren't familiar with. But you got inputs, outputs, and whatnot. And then your screens. It's just a touch screen with another PC on the backside that's registering and talking to that PLC. That HMI, that human machine interface that's on a steel cabinet, it's no different than your touchscreen on your laptop, except that it's got a very dedicated purpose.
Right, and then of course the fundamentals that IT professionals are familiar with, the concepts of strong and appropriate authentication, good user access and authorization procedures, system monitoring from a performance perspective, system monitoring from a security perspective. All of those fundamental ideas, right, translate pretty directly.
They do, yeah. I mean, you've got to know what's going on your network. You got to have a location for logs to go, and then you got to look at them. And they all, I say all. They should. They have those capabilities, and so you've got to have a destination for that monitoring and whatnot. And when you start talking about infrastructure, I mean that fiber, Ethernet, Cat 5, Cat 6, whatever is out in the field. It looks the same. It feels the same. And just like we've been pushing different types of protocols over these cables for a long time. We've just gotten used to the fact that we're just doing TCP/IP on our LANs. But for years, we've been doing all sorts of protocols, and they can coexist. A lot of people forget that, and so that awareness level of different things that are running on your network, but it's still the physical infrastructure is really similar.
Yep. So you highlighted a lot of the similarities. What makes OT different?
First thing we talked about is that physical aspect to these devices. There are implications to having systems that are connected to the real world, and you got to be aware of those implications. You got to think about it. Think about environmental control systems. if you if your house AC goes off, it's fine. But if in a hospital and you've got this whole HVAC system running through HMIs and an entire building ecosystem, and somebody tweaks the hospital's air conditioning, I mean, that can have big implications. So there's that physical aspect to it. And same goes for, oil and gas production or manufacturing or whatever. I mean, there's just physical stuff that you got to be thinking about when you start talking about it. But there are a lot of less obvious differences. OT systems, when they're implemented, there's no, and I say no, they're most likely not thinking about the replacement period. Somebody deploys laptops and they say, okay, this has got a lifespan of 3 years, and we're going to replace it and just have that rotation. Or maybe your server systems or your SAN is on a 5 or 6 year rotation. OT systems generally get implemented and they're like, okay, this is going to be for the life of the building until it breaks. And so there's that intent that it's going to run forever, or at least decades. OT systems, they're much less open to downtime, so the concerns are much more elevated. It's the toaster analogy. Every time somebody puts toast in this thing and they push the button, they expect toast to pop out. They're not thinking, oh, I got to patch this thing later, or every third week we're going to have to take it down. Nobody can get toast. You've got to. Mondays is non-toast day. No, we have to have this every day. It's got to work, and it's got to work all the time. So the system owners are really less open to patch cycles or any outages that might happen. So other
your family likes toast that much?
It's just the toaster analogy.
I gotta be honest with you. I mean, that wouldn't have been my analogy. I mean, I do understand it. I thought the analogy was brilliant, with the exception of the fact using a toaster. I think most people going like, yeah, I can do that toast on Mondays. That'd be okay.
It's just the simple input output.
Right.
Most of you have the people that are implementing the operational technology, but then you have the users, the endpoint, and some dude out in the field, he knows oil and gas. He understands the properties, but I mean, he's pushing a couple of buttons to make sure that the flow rate is right, but he doesn't understand or need to know all of the back end stuff. So in his mind, this is a toaster. I push this button, this happens. And the idea that there's some CPU that has to make sure that this threshold hits this limit and this safety is engaged before it opens that valve, he doesn't care or want to know necessarily about those things.
Right. So so those are definitely some of the differences, and then of course, like from a technological difference, right? Like you said, you've got the computer is different, right? It might be a PLC, it might be some other type of device. Communication protocols are different. The operating systems that they run are different. Anything else from like a technology stack that is significantly different that maybe we can get some comfort level with?
Well, I don't know if this is going to give comfort, but they respond a lot differently to our normal, or what we on the IT side would say our normal day-to-day operations would be. You don't put a vulnerability scanner on an OT network, for example. It can have very unintended consequences. And anybody that's running a vulnerability scanner knows that the first couple of times you may empty a printer out of paper. You hit that printer with the wrong port at the wrong time, and it's going to dump all of its paper. Well, that's fine for okay, we lost 50 sheets of paper. But if you run a vulnerability scanner against a tank PLC and it decides to dump its contents, that's a much bigger conversation. And OT, as a general rule, do not respond well to penetration testing, vulnerability scanning. I've been I don't do it, but a simple Nmap across an OT network can have disastrous impacts. You can even brick a PLC; it'll never operate again. So And hopefully the newer ones they're getting better about this, and I've seen and heard some good reports. But like I said, some of these things have been in place for decades, and
Right.
so that you just don't jump into the middle of that and say, well, I'm gonna inventory our OT network and run this scanner to identify stuff.
Right. Yeah. Because if you think about it, if you go back to the old days, right? I did a little SCADA system work in the 90s, right? That was the kind of the idea of IP connecting SCADA systems at that point was still, new,
Yeah.
right? New that it wasn't something that was big. In the old days, it was a fully isolated. They were fully isolated. So I think that helps to explain why some of these systems have challenges of that nature, because they weren't originally architected with this idea, right? This idea of IP enabling them and interfacing them into the rest of your corporate network, as an example, didn't exist back then.
Yeah, I mean,
So I think that's part of it.
add-on. It's been an add-on to a lot of systems. Oh, we'll
Right.
add this, an Ethernet module to a PLC brick, and okay, now you can SSH into it. Well, now you have remote administration, but it hasn't had the years of troubleshooting.
Now you've got a listening service that isn't mature.
Yeah, exactly.
The other thing too that I was smiling at when you were talking about this idea that it's set it and forget it with OT, isn't that always the case, that the systems that produce revenue, right, the most important systems in an organization generally are the ones that are least secure. Which is contrary to what you would logically think, but it's because nobody wants to interrupt them, either to take them down for any period of time if they're revenue generating, or no one wants to update things if they're working, right? I remember there was a system for a major city that processed all of the credit card transactions relating to fines and licenses and things of that nature, and it was woefully insecure because it hadn't been updated in 7 years, because of the fact that every time they tried to update it, something would go wrong, and the CFO would come forward and say, that's enough. You can't mess around with this thing. So they built all type of compensating controls around this system to try to prevent it, keep it secure, while because they never wanted to touch it.
Well, I have a similar funny, frustrating story. Years ago, I was working for a manufacturing company, and they had an HMI, human interface, that talked IP to this. It was a x86 type system that ran their software. It was PLC controllers, and it died on the plant floor. Stopped production, and I didn't work with them much. Basically, I provided access, and the OT folks did it. But they were like, we can't get this system this week or this month to replace it. And I had already implemented some virtualization, and I was like, well, if you have images, I could probably throw this on a VM while we wait. And so I did. Spun up a VM, and it ran fine. Connected the HMI to it over the corporate network. And this was years ago before I would not. Don't do this.
Wouldn't do it now. Do as I say, not as I do.
Right. Exactly. And I got it up and running, and I was a hero for the day, which was great. I left that company and went on to other stuff. And I actually I ended up working for a technology company that did consulting, and they called me up, and I'm like, Curtis, something's not working. And I was like, I'd love to help you. I'm working for this consulting company. We do that sort of stuff. Call this. We'll get me out there, and we'll take a look at it. Turns out, 7 years later, they were still running on that VM.
Yeah.
That temporary fix was never followed through with. And so
And
I
that
was like,
goes to what I was just saying. No one. If it ain't broken, don't fix it. It's the same idea that you see. Like, I mean, one of the things I always smile about is when people say, "Oh, it's just a proof of concept. Like, we don't really need to follow good security practices with this piece of software." And I'll be like, if the proof of concept works, you're going to use it as a jump start or it's going to migrate directly to prod, and you're going to have a fundamentally flawed piece of software that's no, that's not. And of course, they always end up in production. So same idea.
temporary always goes into production.
That's exactly. That's exactly. So just to kind of double down on what you said before, like one of the big differences, and maybe we should just kind of give a couple more examples of this, is why I think OT is one of those things that people look at differently, is because the implication of a risk being realized, right? These OT systems, they're pressure sensors that should trigger a valve opening on a manufacturing tank if it gets over pressure, and if it fails to, not only do we have a disruption of an entire batch or whatever it might be, but we've got explosions, right? And we've got people getting hurt. Oil and gas, I know you guys do tons of work in the energy industry. Maybe you can talk about oil and gas pipelines, wastewater treatment plants, airfield lighting systems for major airports and things that need, traffic control systems, probably train control, positive traction control systems and trains. Like the implications of OT risks being realized are just insane.
Yeah, the risk to life and limb, especially, but also equipment, destruction of equipment. You can't restore a physical device from backups. That's not the way it works. And so, yeah, we've talked through on the OT side. There's devices that if you spin them too fast, they will break. And all it takes is one limit change, and they'll go too fast, and they can self-destruct. If you have a heater that you change the limit on it, you might have a fire start. It just as simple as that. So yeah, the implications to the real world are definitely a big deal.
Okay. So knowing that the implications are significant, what is the best process for understanding, assessing, and managing risks in an OT environment, right? Is this, do you conduct conventional risk assessments? Do you do vulnerability assessments? I know we can't do active, but there are tools, right, passive vulnerability assessment engines that you might use. Do you do a gap assessment? Some combination thereof. What's your best approach for addressing risk?
Yeah, best is always that loaded question. I would say the short.
No, how about go to?
The short answer for me is a combination.
Okay.
The first part is education. Helping organizations and the IT guys and the OT guys to talk. IT guys and CISOs, they have an understanding of cybersecurity risk. They can't always put a pinpoint on what that means for OT, but I'm finding a lot of times they're not talking to the OT folks, and so the OT guys may have some level of concern about cybersecurity, but again, the OT guys are interested in getting product out the door or producing widgets. That's what the OT guys are interested in. So cybersecurity is not necessarily on their radar. So assessing OT risks is somewhat challenging, partly because it's new. Like you said, the maturity level hasn't grown like it has in IT over the last 10, 20 years. And so we're trying to get them back up to speed, both at the OT side and throughout the organization. We're used to talking RPOs, recovery point objectives and recovery time objectives with executives on the business side when you're talking about your data centers and your enterprise systems. But in many cases, you're not talking RPOs and RTOs with the OT guys. And until you've defined, what those are, it's hard to understand how, what the level of risk is. That's my disclaimer. My approach has been, initially doing some gap assessments, to their environment, understanding where they are, where we think they should be, where they're lacking security controls, that sort of thing. We do tabletop exercises, get people in the room together and talk through scenarios. Hey, if this happens, what are the implications? I really enjoy those. We've had tabletop exercises where IT and OT had never spoken other than maybe getting their corporate laptops, and they just hadn't been in the same place having that conversation. I've talked to OT guys that are, brilliant building systems. But I ask them, okay, so if you got a ransomware screen pop up on your screen, what are you going to do? And they didn't have a response. That's not in their normal day-to-day thinking about incident response or disaster recovery. They've got tons of answers for, if that light's on fire or if, we need to evacuate the site, they've got plans for that. So those tabletop exercises really, really help. It's helpful when organizations have done some sort of business impact analysis already. Thankfully, a lot of places will know, okay, if this site goes down, it costs us X dollars a day to be down. So that helps in that. But then you got to figure out, what technology would cause that outage.
Right. Yeah. Well, what would be the trigger to that occurring, and then how do we protect against that trigger? That trigger actually occurring. Yeah.
And then what's upstream and downstream? Either physically, in a pipeline, or what processes are upstream and downstream in your manufacturing process.
So you said something interesting to me. I don't know if you've ever worked in in the world of TV, right? Networks and things of that nature. But they had a stretch of time where it was very problematic, where what they used to have was engineering and video engineers, and then you had IT engineers. And what happened was all of the engineering stuff was kind of isolated from the IT network. And then, of course, much the same way we're talking about IT technologies creeping into OT, IT technologies crept into what they referred to as engineering and video production. And what happened is we'd have these strange situations where the two ends didn't get together, where there was gaps between it. There was challenges in making that migration. It sounds as if, in, I guess, some of the larger organizations that you work with, you sort of have that same issue, right? Where you've got, almost two camps, if you will, and part of your job is just bridging those camps and getting them to talk a common language and kind of view the world from a more holistic perspective.
Yeah, definitely. Bridging that gap on conversation is huge. Conflicting interests. A simple example. These OT guys, and I say these. I are one some days, but they'll do an implementation, and we've all done it at home, where you get a default router and it's set for 169 or 192.168.1, and you create your network and then you move on. Well, if you've got dozens of these around, and you try and start connecting stuff together, well, there's all sorts of implications about that. And when you're thinking just this isolated system, it's not a big deal. But when you want to start having that functionality of true networks, you've got to think IT planning. And that hasn't been on the radar for OT guys. On the IT side, we've been dealing with it forever. Integration of companies and having to do, either jump through hoops or painful migrations or NAT configurations or whatever. We've come up with solutions, but on the OT side, well, what are the implications on that, and how do we fix that? Because again, we can't take a week and renumber everything. So
what's interesting is we talked about the fact that IT has a lot of similarities and OT has some differences. We're big believers in aligning our clients with what I'm going to refer to as open, trusted frameworks and guidance. So it gets interesting to me, right? I could see arguments for using conventional IT controls as best practices, like CIS controls or ISO ISO 27001 controls. I could see, or what some of the things they do around authentication, access management, logging, things of that nature. Then you talked about the blend into IoT, right? So now we've got IoT guidance. ENISA has some great IoT guidance. In fact, some of ENISA's IT guidance stems down into the industrial Internet of Things, right? Where they refer to that smart factory, I guess they're calling that, right? And then, of course, you've got OT-specific guidance, either directly from the manufacturers of the devices or something like NIST 800-82. How do you typically approach it? Do you use some combination of those? Is there one go-to?
Yeah. First and foremost, if an organization has regulatory requirements, start there. Electrical, NERC SIP gives guidance and direction for that. Or, a lot of the, marine terminals, they've got the Coast Guard has MTSA requirements. They're pretty light right now, but they're getting there. They're starting that process. A couple of years ago, they added to their to the facility security plans cybersecurity requirements, new ads, and so we've helped clients with that. So that regulatory piece, the TSA, has now implemented all sorts of directives, security directives for pipeline regulation, and so. There's that. So, that's where I would start.
Real quickly, TSA is not the same TSA that does airlines, is it?
It is. Yeah.
So the TSA that does, what's that, the Travel and Safety Administration? Is that what TSA stands for?
But yes, it's the same TSA organization at the head. Now, there's different departments, different people.
No, I know that, but I find I'm really, I would have thought that would have come out of critical infrastructure. So, CISA, which comes out of DHS. I wouldn't have thought that guidance would come out of TSA. That's just
it's an odd relationship, but they're the same ones that are governing rail cars and that interstate pipe liquids transportation, stuff like that. So yeah, the first time I had the same question. I was like, is this the same TSA that I have to deal with when I go through airport security? At the head, ultimately. So it's an odd approach. Like I said, that's kind of where I start. And then, honestly, if the company has some sort of already adopted framework, whether that be a CSF or a CIS cybersecurity controls, in order to maintain, you talked about that common language. In order to maintain common language, use the company's established standards. We've got a lot of companies that have that are using CSF at some level or another. Now it's a framework. It's super high level, and you're not going to get specific. Turn this on and turn that off or whatever that you might on the CIS side. But at least it's a framework to start the discussion, and then I supplement a lot with 882 NIST. And the nice thing about the latest revision, it's in draft still, R3, it has a lot of better correlation to CSF and CIS and those other frameworks and those other stuff. So that if a company is using the CIS, we can go, okay, this is what CIS says, 882 has some supplementary information, help us define what things we should be looking at. And then, really customize it for their organization. It gives us a framework to work from, and that language.
Circling back to what we talked about before. So you talked about with many of your customers where there's OT personnel and there's IT personnel. Is that generally the case, or is that just the case when you go into a large organization? Because I've been in smaller organizations that have that don't have massive staffs, and I've seen IT people struggling to deal with OT. How do you typically see that?
There's really three groups. Those larger organizations, definitely there's an OT side and an IT side, and unless forced to talk to each other, they haven't. I think it's getting better, especially with the cybersecurity aspect and people understanding that they want that connectivity. But for the longest time, IT, we'll deliver you a circuit. We might even put a firewall or a router in there for connectivity. But after that, beyond the firewall, it's a black box.
Okay.
So definitely larger organizations, and even more so if they've grown by acquisition. You got this group here, and we've acquired them, and they've got their systems. Okay, we're going to give you the connectivity you have to have, and then we're just going to let you do your thing. And in some organizations, some of those, I've actually tracked org charts where the only place they meet is the CEO, because it's operations and then it's administrative, and they just don't. So even if the CISO or the security folks want to implement some better security, you're having to it's a hard road to hoe.
Gotcha. And then,
sorry, go ahead.
No, I apologize. You didn't finish. Go ahead.
I was gonna say smaller organizations, it's a mixed bag. A lot of smaller organizations are doing, they're consulting it out. They've got service providers or consultants that are doing their PLC programming, their implementations, and then they hand over that toaster, and the operators, the day-to-day stuff. If it's working, they're just doing their thing, and then when there's issues or they need an upgrade or a change or a process adjustment, they're engaging those vendors. But again, then it's on the operator side. We need XYZ, so please come and do it. The really small organizations, I would say, it's a free for all. IT's helping; they're making stuff work.
So how does OT, or maybe I shouldn't say how should OT impact security monitoring incident response, right? So when you're talking about this idea that two bridges not meeting, I'm assuming that what we're going to find is that OT is either not doing the security monitoring, or and where maybe in an ideal world that security monitoring for both OT and IT should be more consolidated. Certainly incident response planning, I would think, would be or should be, but it probably isn't yet. What do you see?
What I see is the OT is not doing any security monitoring. There's a lot of products out there now that do it, and some really neat stuff coming out, and a lot of maturity, even the last 5-10 years, has come into the industry where they understand, security monitoring understands OT protocols, understands real behavior, can do behavior monitoring and trending, so that if something's out of line, they'll know about it and can alert on it. Mm-hmm. The challenge has been this hard line in the sand, both administratively and physically, where we're air gapped, so we're not going to be pushing logs or alerts anywhere else. There's solutions to that now, and you can fix that problem and still not compromise those air gaps. So I would say largely organizations that have regulation, the NERC SIP, electrical grid stuff, yes, definitely mature in those spaces. A lot more advancement. But sadly, in a lot of organizations where regulation hasn't pushed them, they haven't gone.
Gotcha. How does OT impact cyber liability insurance? Can they not get it? Can they get it? Does it cost a lot more? Right. I would think where risk is higher, right, claims are higher. Hence, insurance either doesn't exist or costs more.
It certainly costs more. We've done a little bit of work in advisory work in trying to identify where insurance is needed. I haven't worked for we don't. Well, CBIZ actually does do some insurance work. I'm kind of new to that space. So I don't want to say we don't. We do that. I have not specifically done that, but we have helped organizations try and identify those price points or costs that they needed coverage for, and that's where the difficulty has been, because when you're putting out getting an insurance policy, where does where does cyber start? Is it, if a if there's a plant explosion or a fire on a tank, is it physical property insurance that covers that? Or if it was discovered that, well, that was caused by someone maliciously overheating the heating element, does that fall into cyber? I don't know if we have the answers to that. I know people are working on it.
Right.
But
And yeah, that probably is a pitch for the business side of our house.
I realize that as I start to say.
Yeah, but you do really, like you see the same thing with cyber, with crime policies, right? Like if you don't understand the interaction of the way your policies work with each other, you can get hosed, right? So as an example, I know a client of ours, a major city, a consultant that was working for them from another company on their general ledger application, human resource application, left a laptop in a Korean restaurant that had all of the names of all of the employees and former employees of the city ad infinitum, right?
Wow.
So it was it ended up being like $20 million notification process that they had to go through. What was interesting was it wasn't covered by the cyber; it was covered by the crime because the laptop was stolen, right?
Interesting.
So if again, if you don't understand the subtle interaction of the way these work, so if you are listening and you do have OT, do make sure that you have your policies looked at by somebody who knows what the hell they're talking about.
And I'll add to that.
It's not easy to layer these things together, right?
No, it's not, because if you start talking about, where is it a nation state attack? Now, does that come under actual war on the insurance versus, just your general cyber hacker?
Yep.
So I know that they're starting to increase those. Hey, it's not our problem if a foreign nation is implicated in this hack. So you got to understand where those lines are being drawn.
Yep. We beat this up pretty good. Did we miss anything?
For the people I'm listening, or the people that are listening, I would say culture is a big deal. Get IT and OT talking together. We kind of hit on it in different places, but I think that if they can start talking to each other, see the value in each other's organizations, that's going to be a big thing. And that's one of my soapboxes, I guess, is getting IT folks to talk to OT folks and back and forth, because with that you can actually get some things done.
Yep, and that space in the middle is where a lot of risk exists.
Exactly.
Give me a real world or fictional character that would make an amazing or horrible CISO, and why.
A fictional or a real person? I'm thinking about
now anyone listening now knows Curtis did not read all the way down to the bottom of the agenda.
No, I did. I came up with, I read the questions and I was like,
you have a memory. So you're now basically saying you either have a memory problem or you didn't read all the way down, Curtis. Either way, you're not looking good. So just you own one of the two, and let's move on. All right.
Okay. My memory is what fails me. I'm gonna go with probably the largest operational technology piece of equipment known to man, which is the Death Star on the original Star Wars, and probably the worst CISO would be Grand Moff Tarkin, because he's not a team player. He's unapproachable. He's really even got, how did you put it? Darth Vader on his leash, and he truly believes that his organization and his grand thing is impervious to risk. So that I'm going to go with him.
You're talking like the one guy in America that doesn't know the Star Wars stories, so it was lost on me. I know who Darth Vader is.
Sorry, man.
I know who Darth Vader is, but I think that's about it. I'm not sure about this Death Star thing. I don't.
Okay, the Death Star is that big planet-looking thing.
Yeah. The amazing thing is, like, I I'm not even sure I've ever seen Star Wars, the original.
Well, it is in the original, the 1976 release. So
yeah.
I know you probably
Yes.
weren't alive yet.
Listen, I wish. I may have seen it in the theaters. All right. Well, this has been fun, man. If somebody wanted to get in touch with you, what's the easiest way to do that?
I'm on LinkedIn, Kurt, CURT, GRIFFIN. If you go to the IN dash or / Kurt Griffin, I'm on LinkedIn. You can reach me through CBiz, curtis.griffin@cbiz.com. Love to hear you and assist in some of these things. This is what we do every day.
Sounds good, man. Thank you.
Appreciate it. It was fun.